All right, welcome to the physics review. We're going to look at this one question, and this is a multi-step question that will be really similar to something you might see on the test. So in this question, it is now a long time past Halloween, and the Coolies have some rotten pumpkins to dispose of. Jet decides at a suitable time to throw the pumpkins from the roof of CCS right by the flagpole, a height of 4.27 meters. Jet is able to muster up enough strength to throw the pumpkin with a velocity of 4.10 meters per second at an angle of 12 degrees relative to the horizontal. Unfortunately, Nova is sitting in her stroller at the edge of the sidewalk, a horizontal distance of 4.5 meters from Jet's release point. And we want to know three things. We want to know what is the maximum height of the pumpkin, will Nova be safe, and how fast will the pumpkin be falling at 1 second. All right, so first of all, you might be wondering, how did Jet get up on the roof? And that is a question I can't answer. But there are three questions we can answer, and they're A, B, and C. So before we even start, let's begin by drawing a picture. So we're going to draw a picture, understand the context of the question. So we know that he's 4.27 meters up from the ground. And he is throwing a pumpkin, and this pumpkin is being thrown at 12 degrees relative to the horizontal. So if this is the horizontal here, my pumpkin is going to be 12 degrees. And it's thrown, and it lands somewhere around here, maybe. And we're also told that Nova is around here somewhere. So 4.5 meters from the release point. So wherever 4.5 meters would be. So we're wondering, is she going to be safe? Now, before we find that out, we want to determine what variables do we actually have. So what we want to do now that we have our picture drawn, and I have Jet here throwing the pumpkin off. But now we want to make a list. So we're going to make a list with our X and our Y components. So we know that our horizontal acceleration is 0 meters per second squared. We know that our vertical acceleration is negative 9.81 meters per second squared. I know that my vertical displacement is 4.27 meters. I'm not sure what my horizontal displacement is, but I do know what my Vox and my Voy are. So Vox and Voy, remember, we can determine what these are. So my horizontal velocity as well as my vertical velocity by using our sine and cosine. So in order to determine my Vox, that all I need to do is take my initial velocity, which is 4.1 meters per second, and take the cosine of my angle, 12 degrees. So 4.01, if I round, that's Vox, and we could store that, or we could recalculate later, and my Voy is 4.1 sine 12 degrees. So 0.85 meters per second. All right, now remember, with every projectile motion question, and by every I mean like 99% of the questions we're looking at, we need to determine what the time is going to be. So what is the time that this whole projectile motion, this trajectory occurs? And remember, our time is going to be the variable that connects my X to my Y. So everything going on in the X-axis, everything going on in my Y-axis, up and down. So in order to begin, we need to find time. And in order to find time, there's two ways we can do it. And the first way is by using the quadratic formula. And before we use the quadratic equation, we have to plug it. We have to find out what the quadratic equation will be. so dy, and we get that from this equation, which is one of my UAM equations. So dy is equal to VOY times time plus 1/2 AT squared. If we rearrange this, I'm going to bring my dy to the other side, so I have to subtract it from both sides. And if I rearrange what I have here, 1/2 AT squared plus VOT minus dy. If I plug in my variables, I get 0 is equal to 1/2 a being my acceleration, negative 4.905 t squared, plus my VO, which was 0.85, plus my displacement, which was negative 4.27 or positive 4.27 with my double negative, and that's my quadratic equation I want to use. My next step would be to plug this into my quadratic equation, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. If I plug all my known variables in, this is a, this is b, and this is c. I'm going to end up with negative 0.85 for my b value times, or sorry, plus or minus the square root of 0.85 squared minus 4 times negative 4.905 times 4.27 divided by 2a. 2 times negative 4.905 is going to be negative 9.81, just to save myself some time. And if I plug this in, I get the following answer. Now, remember, you can plug it in all at once, and if you do, you just make sure you use all your brackets correctly. Another thing you can do is do this in stages and store these answers. Now, either way works. If you were to go through it in one calculation, then the first thing I need to do is use my stored value of 0.85, which I didn't store earlier. So if I get that again now, 4.10 sine 12, I'll store that as y. So now whenever I use alpha y, I get 0.85. So I have negative my 0.85 minus the square root of alpha y squared minus 4 times negative 4.905 times 4.27 divided by negative 9.81, and I get my time of 1.02. So time is equal to 1.02 seconds. So I'm going to store this as my time now, as alpha t. And I'm just going to put in brackets here that I'm storing it as t, and so when I want to refer back to that value, I'll just refer back to t in my calculator. Now that I know what my time is, 1.02 seconds, I can solve everything else. And so for my, what is the maximum height of the pumpkin? Now this one I don't really need my time variable for, and I'll show you why I don't need time for this one here. So I'm just gonna separate this and solve for A. So what is the maximum height of the pumpkin? Now remember, if I'm looking for the maximum height, so I'm just gonna say it's at this point here. We know that if I have the highest point from the ground before it starts falling again, my projectile, objects flying in projectile motion are going to reach a vertical velocity of 0 meters per second. And that's going to be my final velocity at this point, which is the highest point before it starts to descend. Because I threw it from, or because jet threw it from a displacement that is not 0, we can't use half the time, right? We have to use my final velocity at this point, which is 0 meters per second. So VF at this point is going to be equal to 0 meters per second. And we want to use one of my UAM equations to find out what the displacement is going to be relative to this point here. So let's make a list of our UAM equations that we can use. Well, first of all, we know that displacement is equal to VOT plus 1/2 AT squared, but we have several other equations we could use. We have VF squared is equal to VO squared plus 2AD. I have VF is equal to VO plus AT. And I also have G is equal to 1/2 AT squared. Now, because I have my final velocity as well as my initial velocity, and I'm looking for my displacement, I want to use this equation here. So VF squared is equal to VO squared plus 2AD. But I need to rearrange this for my displacement. And so displacement is going to equal VF squared minus VO squared divided by 2A. Now, as I solve for displacement, I also have to keep in mind that I'm going to be adding my displacement to this side here, because when I plug this in, I'm only actually solving the displacement from this point to this point, from my initial velocity to my highest point. So when we do that, d is equal to 0 squared minus my vertical velocity, which is 0.85 squared, divided by 2 times negative 9.81. My displacement is going to be so alpha y squared, and that's negative alpha y squared. So negative alpha y squared is negative 0.72 divided by 2 times negative 9.81 gives me a displacement of 0.037 meters. This I'm going to have to add to my total height of the building, which is 4.27, which is where it was thrown from. And this will be my total displacement. And so plus 4.27, we get 4.31 meters. And in a sentence, the maximum displacement and max height of the pumpkin will be 4.31 meters. All right, part B. Part B, we want to know, will NOVA be safe? That's the question we've all been wondering and worried about. Will NOVA be safe? So my formula that I'm using here is going to arise from my VOX is equal to dx over t. I need to rearrange this formula and solve for displacement. And in order to do that, this is the formula I get. dx is equal to VOX times t. My horizontal displacement is going to equal my my horizontal velocity, which was VOX 4.01 times my time. Remember, I stored time as alpha t, but I didn't store my horizontal velocity. So my horizontal velocity now is going to be 4.10 cosine 12 times my time is 4.1. And with sig figs, 4.11 meters. And so that means NOVA is barely safe, because NOVA is at 4.5 meters. So she's good. So since Nova is located at 4.50 meters from the launch zone, she will be safe. By 39 centimeters, in fact. Oof. Okay, last question. We want to determine what's our, how fast will the pumpkin be falling at 1 second. So at 1 second, we need to, again, use one of these formulas. So VF is equal to VO plus AT. So I need to find out the final velocity at 1 second. I know that my initial velocity is 0.85 again, 0.85 meters per second plus negative 9.81. Now, instead of using my stored time, I want to know at 1 second. So multiply that by 1. And my final velocity that I'm going to get is alpha y plus negative 9.81 times 1 is going to be negative 8.9 meters per second. Now, remember that this is going to be 8.96 meters per second, and that's down. And so if I'm going that velocity downwards, my horizontal velocity, remember, was 4.01 meters per second. And I want to know what this is, right? So that's the velocity I'm actually looking for. And this is my real final velocity. In order to get my final velocity, I can use my Pythagorean theorem, a squared plus b squared equals c squared, where I have 4.01 squared plus 8.96 squared equals c squared. And if we plug that in, we get a value of 9.81 meters per second. So my final velocity, at 1 second will be 9.81 meters per second.